Today's lesson is regarding exponential functions, and in specific, working with growth and decay models. We're going to be working with the four formulas you see here. The top left, exponential growth, exponential decay will be this one. If we work with compound interest, our formula will be this one. And compounding continuously is a special formula, and the four formulas are going to be described in detail on the next slides. First, exponential growth compared to exponential decay. Please understand that the value they place in front, the A value, represents the initial amount that we start out with. The R value is representative of the growth or decay rate expressed in decimal form. The T value represents time. And if you put the numbers into one of the formulas and do the math, what you have figured out is the amount you will have after the time has gone by. When we work with compound interest, you have a few different letters in your formula. The A in the compound interest formula represents the amount after the time has expired, or amount after T years has gone by. The value P represents principal, which is considered the amount that you borrowed or the amount you invested. The R value again is rate, and remember we're going to be using a decimal in all four formulas when we put in our number for rate. T represents time, but specifically time in how many years have gone by. The N value is shown up twice in the formula, down here at the bottom underneath the rate, and also up here, zoom in a little bit, up here with the T value. So the N is down low and up high. It represents how many times we are going to be compounding in a given year. You need to write down the formulas or cheat sheet for yourself. If it says compound yearly, you're going to be using the number 1 for N. If it says compound weekly, you're going to be using the number 52 for N. When it says compounded quarterly, 4 goes in the N value down low and up here with T. And for daily, we use 365. Let's refresh our memory on how to change percents into decimals and how to change decimals into percents. To change percents into decimals, you want to make sure to divide by 100, which essentially moves the decimal 2 places to the left. So the decimal format would be 0.34. 5%, if you tried to move the decimal 2 to the left or took 5 and divided it by 100, remember would be 0.05. 3.4% written as a decimal, or 3.4 divided by 100, would be 0.034. 115%. Remember the decimal is represented back here in the back, and so if we divide by 100 or move the decimal 2 to the left, it would land in between the 1 and the 1. So 1.15 is the decimal format for 115%. Going the other direction, we would multiply by 100 or move your decimal 2 spaces to the right. 0.54 written in percent form is 54%. 0.03 written as a percent would be 3%. And 1.3, if you multiply by 100, would be 130%. For the given example, a town has a population of 14,000 and grows at 3.5% each year. What will be the population after 14 years to the nearest whole number? We first need to decide which of our formulas is most appropriate for our situation. It does say that the town grows in population. So the most appropriate formula would be the top one. And what we're going to do is figure out what to insert for A, for R, and for T in the given formula. And I'd like to get my markers to be a little thinner. Okay. So since it is exponential growth, we'll start out with the top formula. The A is the amount we begin with. So initially the population is 14,000. The R is the rate expressed in decimal form. So that's a percent. To change a percent into a decimal, we divide by 100, move it 2 spots to the left. So 0.035. And T, right here in the words, 14 years. So after 14 years go by, we can now use our graphing calculator or delta math calculator. There we go. To type in 14,000 and then 1, add on the rate in decimal form. Remember this caret raised up to the 14th power. So the correct answer for our first question will be, we would have a population of 22,661.7. Notice the rounding, round to the nearest whole number. Our population is going to be 22,662 people. A new car purchased at $16,600. Our value of our car is going to depreciate at 9.75% per year. What will be the value of the car to the nearest cent after 8 years go by? Choose from one of your 4 formulas. This one says that the car depreciates in value, goes down in value. So that one's going to be our exponential decay formula. So we'll use the second one. Using the amount or initial value of 16,600. 1, remove because of the depreciation. Change your percent into a decimal. Move your decimal 2 to the left to change it. So 0.0975. And how long of time goes by? T for time, 8 years here. So on the calculator, we'll start out with 16,600. 1, take off 0.0975, raised up to 8 years. So the final answer is 7,306. And notice they want to the nearest cent. Remember when it says nearest cent, you're thinking hundredths place, tens, hundreds. So the final answer for this one is going to be $7,306.10. Some of your Delta Math questions are going to have a drop-down menu that asks you to choose if it's going to be growth or decay based on looking at your formula alone. So what I want you to understand is the front number is considered the A value. Inside here, it was either 1 plus the rate raised up to time, or it was 1 minus the rate raised up to time. So the first thing you want to look at is inside here, if the number is bigger than 1, even just by a little bit, you're going to choose growth. If the number is smaller than 1, even just by a little bit, you choose decay. If you choose growth, the word increase will show up here. If you choose decay, the word decrease will show up here. To fill in the percent increase for this example, we have to compare this number to 1. How much higher than 1 is that number? So, or some people would say just remove this and the rate of increase is 0.01, but that's a decimal form. Okay, so we have our 1.01. How much higher than 1 is it? 0.01 higher than the original. And you have to remember that that's the decimal form, and we have to multiply by 100 to change it into percent form. So if you multiply by 100, the decimal will go 2 to the right for a 1% increase in that example. The next one will show us how to use the second formula. Given just the formula, decide if it's a rate of increase or decrease and by what percent. First thing to look for in there, this number is smaller than 1. So you would be choosing decay from the drop-down menu, and it will change that word to decrease. But notice it says percent here. So what you need to do is figure out how much lower than 1 did we get. Compare 1 to our number to find out how much lower, how much beneath the 1 did we go. 1, remove 0.63 is 0.37 lower. One more time, that's the decimal. We want the percent decrease for 37% there. Couple more examples. If we invest $2,800 in an account and we know the interest rate is 6.2%, the key is compounded monthly. Assuming no other deposits or withdrawals are made, how much money will we have to the nearest $10 after 8 years have gone by? So notice compounded monthly. When you go to pick out your formula, this is called compound interest, or the third formula down. So to find the amount after 8 years, we will start out by saying what is our principal or amount that we invested. $2,800 is the principal. Parentheses. 1 add, remember the rate has to be a decimal, and they gave us a percent. So dividing by 100 to make it 0.062. And now something that is a little bit new, N. There was a chart in the beginning of the lesson that said for N, you have to look carefully to find how many times are they compounding in a year. There's our clue right here. Compounded monthly. There are 12 months in a year. So whenever they say compounded monthly, we will be using 12 for N, down low and up high. Then T is how many years have gone by, and they gave us amount of years as 8. When you go to type it in, you can do these on Delta Math as well on these calculators. I highly recommend that you use the fraction. So we go 2,800, parenthesis 1, add on. Use the alpha y equal, enter to get a fraction so you can have a top, 0.0 0.062, and then arrow down to the denominator for your 12, arrow out to close the parentheses. Now caret to raise that up to the 12 times 8. You can use parentheses or the times sign for the 8. Press enter, and then we have to be careful how to round. So this one wanted us to round to the nearest $10, not the 10th place, but nearest $10. So if I did 4,592, that's to the nearest dollar. If I do 4,590, notice I went down because the 2 is smaller than 5, that would be to the nearest $10. So 4,590 will be your answer for that one. If we invest $110 in an account paying an interest rate of 4.1%, compounded continuously, figure out how much money to the nearest $100 would be in the account after 5 years. So when you look at your 4 choices for formulas, there is a specific formula for compounded continuously. And that formula is calculate the amount by taking the principal times this thing called E, which is actually a number raised up to the power of R times T, the rate times the time. E is a very specific number, and if you try to see what E is on this kind of calculator, you can do the second button and push that and push enter. Whoa, let's try that again and get rid of the power. Maybe not. Okay, let's try this one, E, see if it'll give us a number. There it is. E is a very special number in mathematics that shows up almost as much as pi. It's 2.718281828, and it continues on forever. And that's why you're going to have a special key either on your keyboard in Delta Math or on your calculator to find E. We're going to go ahead and do this problem, and I'll show you how to type it in. For this one, the principal that they gave us to work with is $110 times this fun number E, 2.718281828, and it continues. The rate, 4.1%, needs to be changed to a decimal, 041, for 5 years. When you go to type it in your calculator, do 110, and then I would recommend doing the second button and then this button, and it puts E raised up to a power for you, 0.041, parentheses, 5, multiplying them up there together. Okay, for this particular problem, the final answer is 122.7525. We need to round to what they asked for specifically, nearest $100. So it's either going to be $100 or $200, depending on how big this part of it is. So if you think, what is it closer to, $100 or $200? 122 is definitely closer to $100. So be very careful with the rounding, and please ask. If you're confused about any of the rounding, I'll help you out. There's a couple more kinds that you're responsible for in today's assignment. And this one is similar to something you're going to be doing. If I give you a quantity and its initial value is 760, and I know it grows exponentially at 90% every week, what is going to be the value of the quantity after 49 days round to the nearest hundredth? Now the trick are a couple tricks in this question actually. One idea is they're telling me every week, but then they said something about 49 days. So the first thing we're going to do is pick out the correct function to work with. We're going to pick out the function where a, parenthesis 1 plus the rate raised up to a time, called exponential growth. Okay. Now, they already filled in the 760, the initial amount. The rate, you have to take your 90%, change it to a decimal, so that's going to be 0.9. But then t is where we have to work a little bit harder. To figure out what we're going to insert for t, you need to switch 49 days into weeks. 49 divided by 7 will tell you how many weeks, and that's the number we use for t. So plugging in 7 for t and then typing that on the calculator will give us this number here. And then they want us to round our number to the nearest hundredth. Notice the TH behind this. So quick refresher, this is the tens place, this is the hundreds place. So this number, the 2, decides if I leave it as 0.25 or change it to a little bit higher 0.26. 2 is a number smaller than 5, so we leave it alone and type this one in. Another similar example to the last one, a quantity starts out with an initial value of 2,300, decays exponentially at a rate of 0.9% every minute, and then they do this to us again. They talk about minutes, but then the quantity after 441 seconds goes by. So notice we're going to use the exponential decay to start our function. Insert your initial amount. They tell you that it's decay, but the minus signs are already in there for you. So we have to change 0.9% to the decimal for here. So the rate is going to be 0.009. But when we go to fill in time, they talk about minutes, but they give us seconds. You have to switch 441 seconds into minutes. So there's our rate changed to 0.009 for decimal. And to change 441 seconds into minutes, you can use the idea that there are 60 seconds in every minute. So if you divide, you get 7.335. Some teachers will teach it this way: 441 seconds multiplied by a conversion factor, 60 seconds for every minute, to explain where that 60 came from. And then these seconds go away. 441 times 1, nothing, times 60, or 1 times 60, will give us how many minutes. So if you remember this from science class, that's another way of getting the 7.35. Plug in 7.35 for your power, type that in on your calculator, and round your decimal to the nearest hundredth. Landon invested $110 in an account paying an interest rate of 4.1%. Notice compounded continuously. So in these problems, we're going to go back to which of the 4 formulas do you think we should be using? Since it said compounded continuously, you're going to be using amount is equal to principal times that special value E raised up to the rate times time. The 110 will go in for our principal. E is a number. Remember, I think it's back here a ways, 2.71828. The rate for this one, we have to change 4.1 into a percent into a decimal, 0.041, and the time is 5 years. So collect your information, plug in, and let's do one more time on the calculator for that. And clear. So we have 110. To find this E on the calculator, you can do second and then this button right here. And then it raised it up to the power already for me. So I have 0.041 times 5 as the exponent. So 135.027, and then make sure to round to what they said. Here they said $100. So is 135 closer to $100 or closer to $200? Closer to $100. That should be enough for today's lesson to help you get through a majority of the problems